Okay, welcome to the next session. But for the first session, we had described about different things, and among that was about the type of chemical equation that was the word equation, formula equation, and the Ionic equation. And the much we had discussed about two types, that is formula equation, and the word equation. And we are left with Ionic equation. And this part of Ionic equation we discussed it as much after finishing this part of step for balancing the chemical equation. So we have almost 4 to 5 steps of balancing the chemical equations. And the first one is about writing the equation in word form. So this one is the first step. When we hear the word step, make sure that everything will be stepwise. You start the first one to the second to the third ones. Don't intermingling between these two steps or among the steps. So the first one here is to write the equation in word form. For example, here already this is sodium. It's reacted with aluminum chloride to form or to produce sodium chloride and aluminum. So this one is the word form. So in part of word form we have already accomplished. So now we jump to the second step, that is write the equation by using the symbols and the formula. For example, here we write this one is sodium, the symbol of sodium, this one aluminum chloride is this one as the formula, this is sodium chloride is this one formula, and this is aluminum and this one, you see. So here we have write already in the part of the symbol and the formula of the chemical equation that's written in the first step. So we're going to the third step. The third step we're going to describe about to balance the equation. It means that when I say we balance the equation, it means that in part of this reactant side and the product side, the number of the reacting species must be in equal form. So how will it be in equal form? The thing that we're going to use here is about the stoichiometric coefficients. And the stoichiometric coefficient we discussed in the first session. And this is about the number of the molecule that's laid in the sides. For example, here we have one sodium in part of the reactant, and the part of the product we have one sodium, so it's already balanced. In the part of aluminum, in the part of the reactant side we have one aluminum, and in the part of product side we have one aluminum, so it's already balanced. In the part of chlorine, here we have one chlorine, but there are 3 chlorine, so it will be 3 times chlorine, so we have 3 chlorine. And this part of the product we have 1 chlorine, so until the end we will put 3 here is the as the stoichiometric coefficient, or the balancing number between that species. So until the end here we have 3 chlorine, and here we have 3 chlorine, but also we have 3 sodium, but previously we have 1 sodium in the reacting species. So until the end we will put 3 here. So until the end here, if you try to look the number of species in a part of reactant and the product side, it will be equivalent or equal from each side. For example, here as I write. And the fourth one is include the straight symbol. When you say the straight symbols, it means that we're going to look about the solid form, the liquid form, the gas form, and the aqua form. So we have almost 4 straight symbols. And normally we say that all metal atoms are solid, most of them. And also we can distinguish maybe the mercury. This one is liquid in nature. And part of the non-metal, most of them are gas in form, but except for carbon and sulfur, these are solid in nature. So when you use the set symbol, when you see this element are reacting with a certain compound or a certain formula to form a certain product, make sure that when you see only the carbon is present on that product or the reacting species should be written in solid form, since naturally it exists in a solid form. And from that, when you see the aqua, as I said that this one is dissolved in water. So from this stage is what we're going to balance the chemical equation. So right now here we include the state symbol here. Sodium is solid, aluminum chloride, it means that it's dissolved in what is aqua, and this is sodium chloride is aqua, and this aluminum is salt. So from that you will say that you have balanced the chemical equation in such manner. So make sure that when you write the chemical equation, you follow in these 4 steps, but for some time they write the 5th stage, but in the 4th stage is enough for you to balance your chemical equation. So right now let's jump to the next step, and this one is about the different questions that I provided to you. You may try for yourself, but first of all I'm going to show how to balance this equation by showing an example for the first trial. And this one, I said that when you say balance the chemical equation, you must consider a lot of the information. But when you see from this equation, most of the information is already accomplished until the state symbol. You see? So if the state symbol is already accomplished from your equation, the major things is to write the stoichiometric coefficient that is needed to be balanced in order to make sure that the number of the productive species and the reacting species are in equivalent form or are in equilibrium form. So until the end, you're going to describe here. Here we have 1 calcium in part of the reacting species, and the part of product species we have 1 calcium. So in part of calcium, we can say that it's already balanced. So on another side, we're going to look about oxygen. So when you see these blanks that is written with the 2 in the outside, it means that here it will be 2 times oxygen. So here in part of the reacting species we have 2 oxygen, and in part of the product we have only 1 oxygen. So we will put here 2. So until the end it will be 2 times oxygen, it will be 2 oxygen, and also here we have 2 oxygen. Right now we jump to the part of chlorine. Jump to the part of chlorine here. In the part of chlorine, we have 2 chlorine in this side of reacting of the product side, but in part of the reacting species we have only 1 chlorine. So until the end we will put here 2. So until the end here in part of the reacting species we have 2 chlorine, and in the part of the product we have 2 chlorine. So in the part of chlorine now it's already balanced. So in part of calcium, oxygen and chlorine it's already balanced. Right now we jump to the part of the hydrogen. In this part of hydrogen, here we have 2 hydrogen, and also here we have 80 hydrogen. So it will be 2 times 4, it will be 8 hydrogen plus 2 hydrogen. So in the part of the reacting species we have 10 hydrogen, you see. But in part of the of the product side we have 3 hydrogen and 4 hydrogen, to be 7 hydrogen. So until the end we can leave it as first, but we just look on the part of nitrogen also. We have 2 nitrogen in the part of the reacting side here, but in the part of the product we have 1, so we put here 2. So after looking here, it means that this part of nitrogen have 2 and also have 2. Part of hydrogen now it will be 6 plus 4, it will be 10, and this one is 8 plus 2, it will be 10. So the number of the stoichiometric coefficient from the balanced chemical equation is already balanced. So until the end we will be having the product like that one. Here it will be 2, also here it will be 2, and here also it will be 2. So we say that the equation is already balanced in such a manner. So until the end on yourself you can try from this those equations that I have provided to you. So right now let's jump to the next step, that is the ionic equation. At the rusty type of chemical equation. So this ionic equation, we said that the ionic equation is the equation which is written in means of ions. So it means that when you say with the ionic equation, we said that is the type of chemical equation which is written in forms of ions. And ionic equation is the equation whereby the spectator ions are omitted. So we can say that ionic equation is the chemical equation whereby the spectator ions is not involved from the chemical reaction. And when we hear the word spectator ions, these are ions that does not participate in the chemical reactions. So we can say that the ions which exist as the reactant and the product in the chemical equation. It means that this species almost, when you look in the part of the reacting species and the product species, always is tend as it. So it means that it seems like an spectator ions. So we say that is spectator ions. So it seems like a precipitate that is dissolved in a certain solution, but it is not a precipitate as in such, but it seems in form of dissolved form. And most when we look about the cancelling this spectator ions to get the ionic equation, the thing that we're going to note here is about that spectator ions is obtained from only the aqueous equation. And most when you're balancing this chemical equation, in particular for ionic equation, we dissolve or we split only the aqueous compounds. So the aqueous compounds is the one that is splitted, but in part of solid, liquid, and the gas, we leave it as it without splitting it. We are together. So let's look right now how the ionic equation seems like. Maybe here we have hydrogen protons. When it's reacted with hydroxy ions, we get the water, that is what neutralization reactions. Also we have this ammonium protons. When it is reacted with the chlorine ions, it forms the chlorine ions plus ammonium gas and the water. Also in the part of silver, here we have silver ions that is reacted with the chlorine ions to form a silver chloride that is solid form. So until the end we said that these are ionic equations. So right now let's jump to the part how we can balance this chemical equation, particularly in ionic equation. So we follow in different steps. For example here, the step for writing the ionic equation, the first one is about write the equation in word form. As I said previously, since that we have already discussed about that issue, and as it seems here the first example. So for the second step is about write the equation by using the symbol or the formula at the first, as I said in the part of the formula equation. And the third one is to balance the equation as the previous we have discussed. And the another thing is to split all soluble compounds into independent ions. But here in the balancing of chemical equation, make sure that you add the state symbol. State symbol must be written from your species that you have right. So until the end now, we're going to split only the soluble compound. When we say the soluble compound, it means that only the aqua compounds, but other like solid, liquid, and gas, we leave it as it without splitting. For example, from this chemical equation, we have this sodium that is reacted with aluminium chloride and to form what? Sodium chloride and the aluminium. Here we try to look that this aluminium chloride are aqueous and this sodium chloride are aqua. So from there now, what are things we're going to describe about this one? This sodium, it will be remain as it because it is not aqua and it's a solid form, so we leave it as it. And also we jump to the next step, that is aluminium chloride, this one. So we split it as aluminium ions and the chlorine ions, and make sure that the number of the molecule for a certain atom or a certain gas must be written in beside as written here. This one is 3 and the 3 is written in this side, you see. And also we're going to the next part of what of the product. We have a sodium chloride that is aqua, so we split it into ions, so it would be sodium ions and the chlorine ions. But this 3, it was for sodium and the chlorine, so we write here 3 as the stoichiometric coefficient, that seems like this one. So it will be 3 sodium ions and 3 chlorine ions and the aluminium solid. So we say that with this one we don't split into ions, we split only the soluble compound that is aqua form. So this one we say that is the fourth stage. we're going to look about the fifth stage. And for some time, when they ask you to write the total ionic equation, this one is the total ionic equation. The total ionic equation, it means that it comprises the spectator ions, and the other species, maybe the solid, liquid, or whatever. So it means that all the charged ions without cancellation and the other species like solid, liquid, and the gas that is shown in the chemical equation is what we call as a total ionic equation. But when we look about the net ionic equation, we must cancel the spectator ions. As I defined from the previous, I said that spectator ions are ions that does not participate in the chemical reactions. So now we're going to look at what spectator ions seems like. From this stage here, we said that cancel out spectator ions and write the net ionic equation. So this one is the total ionic equation. So now we're going to look about the net ionic equation. The net ionic equation is obtained, as I said previously, by cancellation of the species that is known as spectator ions. Here we can look that when we say spectator ions, it means that here when you say this one is being similar with this one, it means that this one does not participated in the chemical reaction. When you hear this one is sodium solid, but here it is sodium aqua, so this one it is not spectator ions. And also this aluminium is aqua, and this aluminium is solid, so this one it is not spectator ions. So the spectator ions is chlorine ion. So until the end we cancel these spectator ions out throughout. So we cancel this one and we cancel with this one. So until the end we write the net ionic equation as written in a sixth stage, as sodium when reacted with aluminium ions is tend to form the sodium and aluminium salt. So this one is what we say as a net ionic equation. The net ionic equation is obtained by cancellation of these spectator ions. We are together. So right now on your ability, try to express this one. Write the ionic equation for the molecular equation below, that's barium chloride, ammonium, and this one. So make sure that you write this precipitation reactions into ionic equation. Try to form all stages that I have shown to you about to form or to dissociate all the soluble compounds and to leave other like liquid, solid, and whatever, as I said previously. And until the end write the total ionic equation, and after that cancel the spectator ions and write the net ionic equation how it seems right. So we have a lot of examples. For example, here write the ionic equation for the following molecular equations as written here. So on yourself, try to practice on this exercise, and after that you will conceive a lot of the information from this part of the type of chemical reaction that is ionic.